Let us see some of the applications of stack. This particular data structure, it gets utilized in the applications. One is recursion, second one is nested function calls, third one is expression conversion from infix to postfix. Let us see let us have a discussion on these three applications of stack with examples. First, if we consider recursion. What is recursion? Function calling itself. The process of function calling itself is defined as recursion process. For this, if we take the example of factorial calculation. In the factorial calculation, how stack is required. We take something factorial of 5. So it is 5 factorial we have to calculate. How the process is done actually in the calculation of factorial? It is that 5 into 4 factorial. It's a recursive process. 5 into again factorial of 4 we have to calculate. So it is again 5 into 4 factorial can be defined such a way 4 into 3 factorial. So it is 5 into 4 into 3 into 2 factorial. 5 into 4 into 3 into 2 into 1 factorial. So we are getting finally 1 factorial equal to 1. So it is 5 into 4 into 3 into 2 into 1. So here in the process of factorial calculation using recursive procedure, we are getting some intermediate results here. Here finally after getting this 1 should be multiplied to 2 and this result should be multiplied to 3 and this whole result should be multiplied to 4 and this whole result should be multiplied with 5 so that it gives the value of 5 factorial. For this, we can write the code factorial of n. It is that factorial of 1. For this recursive procedure there should be a stopping condition. Here the stopping condition is if the n reaches 1 and reaches 0, our factorial value will become 1. Else, I have to define the recursive procedure. Fact equal to n into factorial of n minus 1. Every time we have to catch up this coefficient part of this recursive function call and we have to put into stack and finally we have to multiply all that so that we can get the final value of the factorial. So this is the code and for this particular thing, how stack is utilized. Here stack will use for storing the intermediate results as part of the calculation of this factorial. Once we are at the first step, 5 factorial is given. First time when the function is called, n is 5, 5 is not 0 and here we will get fact equal to 5 into factorial of 5 minus 1, it is 4. This is a function call and here we got the intermediate result 5. Here as it is function call, control will move from here to again the function definition with a new value 4. So while repeating the execution of this for the next time, all these intermediate values we have to store somewhere. So we will get 5 here. In the next iteration, this will become 4 into factorial of 3. So we will store that 4 here. Next iteration 3, next iteration 2, next iteration 1 and here factorial of 1 sign becomes 0. It gives a resultant value 1 and we have got all these values. Now what we have to do is we have to multiply all the values. It is 1 into 2 into 3 into 4 into 5. So in the recursion process to be implemented, stack data structure is utilized. And the next example is nested function calls. What is nested function calls? If you consider 4 functions, function A, function B, function C, function D, and if considering the definition of function A, as part of function A definition, there are some statements here. As part of the statements here, we got the call for function B. Function call for function B. And now if you see the definition of function B, in the definition, in addition to the statements of function B, there is a call to function C. And as part of the definition of function C, you can observe there is a function call to D. If you consider a code which is having 4 functions, involvement of 4 functions, assume that execution has started from function A, and the first instruction of function A gets executed. We know that whatever instruction that has to be executed, address of that instruction to be referred, that will be there in the PC program counter. So assume that here the address is 100. So PC is having 100 address. So once PC is having 100, your control unit computer will refer to this particular instruction. Next it will refer to the next instruction 101. Next it will refer 102. Next it will refer 103. And next, when it is referring 104 address location instruction, it is not a single instruction to get executed. It is a function call. So what should happen? As it is function call, control of execution should go to its definition. But here one thing we can observe, after this function call there are other statements to be executed. So once this particular execution of this function is done, control has to come back here to continue with the execution of remaining instructions of this function A. So before the control moves from this function call to its definition, we have to store the address of the next instruction after this function call somewhere. For storing these address locations, we have to use compulsorily stack data structure. So here this is 104, so the next location will be 105, and this 105 will be storing into stack. Then control moves from here to here, and assume that this is 201. So it is 202, 203, 204. While referring to 205 instruction, this is again a function call. This is not a normal instruction. So control has to move from its call to its definition. Before the control moves there, it has to store the address of the next instruction somewhere in the memory. Here it is 206. 206 gets stored in the stack. Now control comes here and it is the execution of function C code. It is 301, 302, 303, 304, and here 305. Again it's a function call. So what it has to do? It has to go for function D's definition. Assume that D is not having any function calls. So from here control comes to its definition. But before moving the control here, it has to store the address of the next instruction 306 somewhere. So we are storing that into stack. And here one thing we could observe, after the execution of function D completes, control obviously it has to come to the first address location 306 because it is the previous execution part that was done. So among all these 306, 206 and 105, in order to refer 306 first, obviously here we have to use a stack data structure so that this 306 is available on the top. The latest function call whatever is there, its address we have to store on the top to be referred immediately. So this is how it happens. So function D completed, it will refer 306, it will continue the execution of this. Once this is over, control moves from function C to function B, this part. How to get this address? Again the top of the stack, it is 206. Once this is over, this part is over, control moves back to the next instruction after function call B. It is 105. How to get this address? This address can be retrieved from the stack as 105. So this is the second example to understand application of stack.